Audio check. Okay, I think we're good. Straighten the straighten it again. Okay, I think we're good. I still see it coming in. Papers. All right. Before I even share the link in my Discord, I think I'll finish grabbing papers that we can do. We already did that. Okay. Let me grab something from here real quick. Oh, we could talk about depth anything v4. Although I wasn't really following what happened to it at all. Wait. How am I not? Dang it, 1 second. I opened the wrong window. Like I didn't do my profile. I did not do my stream profile correctly. Okay, now I have it. Now we can look at this. Yeah, what's a good way? The problem is I didn't pay attention to depth in anything before I saw it disappear. Maybe we can try to reconstruct what happened a little bit. I kind of only know the middle and how it ended. Although maybe the others are kind of like self-explanatory. All right, I can transition back. There we go. Open the papers. Oh yeah, this one. And that one. Okay, that's good for this group. Let me find a couple more. Have some from another group. And were there any model releases? The weeks really blur together for me when it comes to model releases. Are there any tech reports too for things that were already released? Stuff that we would have liked to see. I'm gonna rely on y'all to help me with that because I'm gonna miss a lot of stuff otherwise. Let's see. Is this interesting? Nah. Okay. Nothing from there. I feel like I'm still missing something, but that's okay. We can always just, I mean, this is still plenty of stuff to look at for a minute. I will check leaderboards to see if I'm missing some release. Oh, I guess we didn't talk about WAN 3, but that's been on the video leaderboard for even more than a week, right? Or did it show up this week itself? I don't know if there's any detail about it though, really. I was looking the other day. I wasn't even finding like API yet. Okay, and this is like some of these are scam sites for sure, right? Like what's the right one? It's in public beta, 30-second 1080p. Oh, I guess this is from like a tweet from them, right? And this is going to be like the blog announcement that maybe has like a little more detail. Okay. So we got WAN, although it's been in beta since, well, when was that tweet? Oh God, why do I click so dumb? Okay, we'll just look it up again. WAN 3 public beta 2 weeks ago. Okay, so we just kind of missed this. That's okay. We'll catch it now. Anything else? anything here look unfamiliar to us? Oh, have we been able to talk about GLM 5.3? That does not sound horribly familiar. But is there even anything to, like, talk about? Oh, we could have been able to talk about it. Okay, we can talk about it today. I don't think I talked about it last time, even though it was, like, the Friday before this last one. Okay, so we got that. So we've got a couple of, like, releases. Howdy to whoever's watching right now. Feel free to say hi. Okay. Let's open this. Let's, I don't want to look through actual Twitter threads. Yeah, we'll grab, like, the paper. Or we can look at the project page. I don't really want the stream to become like a reading Twitter thing, in part because I just really dislike how the site is designed. Okay, so with this, let's start with this because there's actually nothing technical to go over. This is like just drama. The thing is, I'm not sure. I think we can speed run the interesting parts of the drama here. What we're not going to get is the scope because I'm not really sure where exactly the discussion happened. I had it like as a water cooler discussion, basically, like in person with people. But I'm sure it mirrored discussions that were happening online. Let me make sure real quick that my stream is caught up to me, or like that I'm okay. And my audio's good, yeah? Okay. So, Depth Anything v4, as the name implies, there are like 3 major previous versions of Depth Anything. The weird thing about this Depth Anything v4 is like if we look at the other entries in the series, we'll see like these authors, right? And like let's look at Depth Anything 2. Okay, it was showing 2 and then it like changed it to 3 right as I was stupid enough to click. Do these even have any authors in common? Or has it always been updating? Yeah, it's got some. Okay, like Joshi, for example, is on both. Oh, and Bingi is on both, right? Bingi here, here. Okay. So these have common authors, right? If we go back to Depth Anything v1 or just Depth Anything, we'll also see like some of the same names, right? In fact, same exact names as v2. So v1 and v2 are like exact same author group. v3 is some of the authors from v1. What you'll notice here, Zhao Mingjian, Jinling, and Chenbin, no common names, okay? So people are already saying, like, even when just these results came out, these authors don't seem to be related to Depth Anything v1 through v3 though, right? Which is a really good point because like it's weird to take someone else's naming scheme and act like you're like a follow-up release of their model when that's not your paper, or like not your series. So it's not like that it's unacceptable. Like, where is the line? I think you shouldn't ever do it. I don't know how bad it is. On its own, it was only bad enough, I guess, to make it seem suspicious. Because it's like, who would do such a faux pas? Hey, a duck that strong. Because, like, who would do a faux pas like that? Maybe somebody who doesn't know how to do research in the first place. Speaking of... Wait, what? How did I end up with the same tweet open 2 times? Whatever. The corrections here. Quick heads up that Depth Anything v4 was withdrawn after its central claim was found to be false. The issues go beyond reproducibility and include fundamental consistencies in the paper itself. So anyway, the paper was out, and now it's gone. I don't know who proved that it's false, though. I haven't, no one even told me that part, so I don't know where that discussion exists. This to me just implies, some discussion. So if any of you have that tweet, please share. I'm interested to see. Anyway, that was Depth Anything v4. Quick little drama segment. Let's see, what do we have in terms of tech report type stuff? We have these, right? The rest of these are like papers. So let's look at these tech reports real quick. So we have GLM 5.3. It says right at the top, basically, all they did was scaling post-training. Oh, like literally just scaling post-training. So they built the stack with GLM 5.2. They built something for efficient long context. They built something for RL and long horizon tasks. And they built something for large-scale asynchronous training. So that they could do long context, long horizon, fully async, lots of sandboxes. So 5.3 is the same base model as 5.2, just more post-training. And the capabilities it's supposed to have, by comparison, they're going to open source it. It's going to have stronger coding. It has stronger coding. 50% of their in-house benchmark. That's crazy. And way better for cybersecurity exploitation stuff. Deep Sui. Yeah, it's interesting. They say it's like 50% better than 5.2 on their internal coding benchmark. It's also 50% better on Deep Sui. Uh, hmm. Still behind Kimi, behind Anthropic, behind GPT 5.6 Sol. It's pretty decent though across the board, and on all these important ones that they measure, including GDP val, it's clearly better than GLM 5.2. Interestingly, it beats all these guys on GDP val. Huh. For those that don't know, GDP val is, we can just go to the AA website, like GDP val AA. It measures the ability of models to do economically valuable tasks. Documents, slides, diagrams, spreadsheets, with mirroring actual work products across finance, healthcare, legal, and other professional domains. So my understanding has always been that this benchmark measures things that are worth money that aren't coding. Even though some of these things you can make with code, right? Like spreadsheets. But anyway, so yeah, that, do they even share more technical details? They pushed environment scaling towards tasks that look less like coding exercises and more like real units of coding work. Some represent several days. As agent capability improves, the difficulty moves from the model to the environment. So a useful task environment has to be verifiable, and they need lots of them. So they built pipelines that synthesize environments, right? So they're not just human-built RL environments, they're environments that are synthesized end-to-end, including the RL signal. None of this is like that crazy compared to what anyone else is doing right now, to my knowledge. I'm looking for something that maybe is kind of different. Um, is their context like competitive right now? Or are they also one of the 500K context models still? No, they're 1 million context. Okay. Yeah, they're 1 million. They're not, it's not like Grok like 500K. Okay. That would have been pretty funny if they talked about being able to scale like everything around the long horizon and like the long range tasks. They're still at like 500K context. But I mean, that's kind of what Grok is doing, so I don't know. Maybe it's not funny. Oh, here's the paragraph. Okay, because what I was hearing is that they claim like, oh, cyber capability on par with or better than Mythos. So they run it on the same benchmarks that some of Mythos's big results were reported on, and that's where, okay, so on CyberGym they beat Mythos 5. Um, but not even close on Exploit Bench. Exploit Bench there at 54.4. Mythos and GPT are like in the high 70s. So it completes the tasks within 2 hours and 105 tasks within 2 hours, 130 within 6, which is like way faster than GLM 5.2. Which is interesting because if you look at the leaderboard, is it like supposedly cheaper per task? Same base model, right? It's more expensive per task, which is interesting. Which is really interesting, right? Because they'd assume more tokens, but then supposedly it finishes all the tasks faster. Maybe it's really fast for these tasks, but not others, or who knows? Quirks of how different benchmarks work. I have no idea. Do the capabilities transfer beyond controlled benchmarks? yeah, finding a lot of real world vulnerabilities and stuff. And this is where they report some of it. Um, some of this gets more detailed than we normally like to go to. I'm just kind of skimming for more stuff. Okay, I think we're through with the actual like technical detail, other than stuff that's like super deep. Oh, sorry, Duck. Okay, it might be relevant to what you were doing, but I'm in third year CS student and I'm finding a research gap for neurosymbolic AI. Neurosymbolic AI? I don't know anything about neurosymbolic AI, except that those folks sometimes antagonize people doing data-driven AI, and vice versa, I guess. Sorry, it's hard for me. Yeah, I can't recommend something specific, like in terms of what you would do for that. I can recommend the same general things I recommend to everybody, which are like, especially if you're still in your undergrad, find the course that corresponds to this, talk to that professor, or find the person at your school CS department that works on that and talk to them. Although I don't know if every school even has somebody that does neurosymbolic AI. Maybe outside the CS department sometimes. I don't really know. That's like it's funny. I like hypothetically I know most like I at least know who to talk to or what to try to do to get into most things related to AI. Neurosymbolic AI is not one of those things. Sorry, Doc. Hey, Sam's, good morning. Lone says, hey, Matt, what AIs are you using for research today? The only one I get totally for free, GPT 5.6. I use like Sol Ultra for most things. I'm trying to use it for less things though. Um, yeah, I'm trying to use 5.6 Sol for less. I'm sorry, I'm trying to use Sol Ultra for less stuff because like I can ask it the most simple question and it'll want to spin for like several minutes to give me an answer. Not even several minutes, like sometimes like 10, 20 minutes, right? Um, not but the thing is, I was pretty happy with what I was getting from these models like 3 months ago. Soul Ultra wasn't out 3 months ago. So like I go and I look at benchmarks. Like if I look at here, um, if I look at all models, right? Like I was very happy with, um, I mean these are kind of all over the place, huh? Where's 5.5 extra high? There it is. Like I was pretty happy with 5.5 extra high, which means like I should be for those tasks, I should be maybe even happier with Terra. Um, I even found a lot of use out of 5.4 back when I was using 5.4 a lot. So it's like, can I not use Luna for some things? So that's what I'm trying to get better at. Obviously, I can use Ultra and just trust it to delegate, but I find that there is still some like just baseline latency even in Ultra's orchestration of subagents doing these things. And it doesn't always seem to know like I don't know. I'm often I find that I really have to overcoach Ultra to use subagents effectively. Like I'll often ask it to do something, and I'll be like, "How long do you think for this to finish?" Not that its estimates are always super bad, but what that tells me, I like asking it ETA for two reasons. One, it tells me like exactly in the current moment what it's planning to do, without me having to like trust that it's actually working through the checklist plan or whatever that it cycles through. The other thing is it'll expose to me if for some reason it's decided some work item blocks another work item. And I find that it does it all the time. Like items that could be totally parallel, it'll just randomly have blocked with other things. And I'm like, can you just have a subagent do that? It's like, sure, I can. Um, but it's not often doing that in the first place. Even if I do just give it the generic, like, oh, you subagents all the time, or point it to some skill, it's like, oh, you use subagents for this, 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 that. I find that it's still like, I don't know. I don't know. Okay, Duck says at Swinburne we studied symbolic as part of Intro TI unit. I mean, hopefully, if you had someone willing to stand up and teach an Intro TI unit that included symbolic, they could tell you better than me where that gap is, or who to talk to get more into that. Okay, this is crazy. I need to stop looking at analytics because YouTube is insisting I'm at 0 concurrence, and y'all are talking to me, so I'm like kind of losing my grip on reality. Um, hey Raj, how's it going? Okay, so WAN 3, I don't think we're gonna get like any detail here. Oh, intelligent duration feature, that's cool. But I think what that is, I don't know if it's coming from the LLM or not, but it's definitely just something in the rewriter layer that gives duration alongside everything else. The interesting thing though is like, depending on how your JSON is structured for your video that you're going to generate, your JSON itself has a dependency on the duration, so it's kind of a chicken egg problem. So that's weird. Like you get a human prompt. At what point do you know the duration it should be? Before you do the prompt rewrite? After you do the prompt rewrite? Somehow in parallel? I wonder. Because that can actually matter quite a lot. Yeah, so it's multi-shot, which is expected most... What the... What the heck? What happened? Why are we... What? Sorry, I'm bothered by... So this drone explodes before it collides, by the way. Like, it's not close enough to that, whatever that is, to explode, but it's exploding. And then that's like just a transition to a flower, I guess.
Objective lost.
This is creepy. Why are they skeletons? Germination complete. This was gonna have subtitles? Okay, that's so weird. This is really weird. Here, I'm gonna bother you guys with another one. Oh, can you hear it, by the way? Do I have the audio? Let me double check. Do I have it configured? Yeah, I do. It shouldn't be blowing your eardrums out either. It looks like it's even quieter than my voice. Okay, cherry blossoms. Doves. It's interesting to me that both of their demos are animated. Like, it's interesting to me that neither of them are realistic. The ones that they chose to show. I mean, there's a lot of demand for that in, like, film and animation industry, but still, like, I don't know. As someone who works a lot more, I guess, on, like, realistic video generation, uh, like, I've mentally conditioned myself to be repulsed by the animation, or, like, the 3D render style. Anyway, major differentiator for WAN is its broad multimodal input capability. Was this written like in a time machine a month ago? I don't think that's a differentiator right now, right? That describes the inputs of LTX 2.5 Pro fast. It describes the inputs of CDNS 2.5. It describes the inputs of H3 Minimax. It describes the inputs of a couple others, maybe too. Um, This, though, might be more, I should have finished the sentence. This might be a little more unique. Um, yeah, actually, I'm not sure who else supports web page and document and PowerPoint input. I kind of want to see it. That's the demo I want to see. Where's the PowerPoint to video? Like, what's that looking like? To address the visual drifting and distortion, high precision visual continuity, um, interesting that it says highly realistic human faces with synchronized micro expressions. I mean, is this emerging natively from the like joint audio video conditioning, or does this almost imply that they even maybe in post-train, if nothing else, had some loss to specifically try to get the human faces to be really realistic? And also kind of funny to talk about how realistic the human faces are. Meanwhile, in the demo, what I get is like the world's least emotional robot man. How emotional, how emotive. Why skeletons too? It's freaky. It's just freaky. Oh, are the skeletons designed the same between the different cuts? Like he's got this little thing on his head. This is actually nothing. This is like kind of like a hallucinated like part of a headset that I think is just kind of floating in thin air, like coming out of his jawbone, sort of. Some of it comes into the. But anyway, let's just see. Do they all have the red thing here? Do their shoulders have like the circular thing? I'm kind of curious. Oh, actually, it looks like it's supposed. See, okay, it's obviously not supposed to float. It plugs into the back of its head, right? But it's definitely floating there. Like we get some daylight. Um, that's consistent. And then the visor, like the color is just different, right? No, 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 no. This one doesn't have a visor. I mean, maybe the visor's optional, but it looks like it's straight up plugged into his eyeballs here. Is it plugged into this one's eyeballs too? Yeah, I guess it forgot that they have stuff plugged into their eyeballs, maybe. Well, in this case, it actually, like, if you look at the blur, it decided that the red is centered on the eyes, which is wrong. The red is supposed to be in a bar, right? It's forgetting it as it goes through in fast motion. The motion though is decent. Like there's not warping as we fly. It's not warping. It's not blurring in ways that seem super unnatural. The only weird part is like how, like I said, like the timings on the crashes don't really make sense, and this transition's just like, what the hell is happening? Um, no tech details though, so we can really only guess. I will say though, like based on how other studios have been using work, like I haven't used Wim 3.0. I'm assuming based on the like how these capabilities match and these capabilities match the other like competitors. When they say they're taking like text, image, video, audio, PowerPoint, whatever, you can give it like 20 of these different ones to generate the same like 30-second video. Um, when they have something out, maybe we'll like try it on the stream or something. I don't know. Okay, sorry, I'm not looking at chat while I kind of ramble. Okay, but luckily I'm not out of date with chat. Okay, I think that covers models for this week. Does anyone know one that we didn't talk about? And I'm gonna make a video alone about my AI usage. I have way better stuff to talk about now. So I've been using it for every part of the research conference cycle except my own reviews, which I do myself, and except for like I haven't written a paper with it yet, I guess. But like for so I guess that doesn't leave too many things. I've been using it for like rebuttals, for posters, and for slides for the talk. Um, I don't know if it's saving me time though, because I was kind of like I was trying to practice some ownership, like, oh yeah, my ECCV paper, I made this with GPT 5.6 here. I'll show you guys the poster. Um, I need to figure out how I want to talk about this when I actually do like a proper video. So I'm not too concerned with like, oh, why am I talking about it now if I'm supposedly gonna make a video? Like the video will just have to be like more polished than how I'm going to explain it right now. Let me download the poster real quick and then I'll put it up. I made it on the other computer. Can we please download? No? That's kind of evil. Come on. Go gadget download. Anybody know that film? Scanning for viruses? That's the longest virus scan of all time. Okay, here we go. Here we go, here we go, here we go again. All right. Hey, Kunte, how's it going? Cool hair. Me? Cool hair me or cool hair? Were we looking at cool hair somewhere? I don't know. Me? Okay, so this is an example of something I made with my AI. I'll tell you what it made and what I made though. Obviously I wrote this paper. And I wrote this paper with zero AI. Like zero, zero. Not even on the code. This was in my like no AI era. So like all the code for this project, no AI. However, I started using AI for this at the time that I did the rebuttal for the second conference I submitted to. This one, ECCV. Um, I like AI for conference rebuttals for two things. And okay, so for those of you that don't know what a conference rebuttal is, they just know what a conference is. Maybe even for those of you that don't know what a conference is. Maybe we have a viewer here who doesn't know what a conference is, and I'll explain it very briefly. Uh, you can write a research paper, right? These things that we look at the whole stream. You can post it on Twitter or like host it on your website, or you can submit it to a venue where it undergoes peer review, which means that other scientists, normally grad students, read the paper, typically like three of them, and they say what they think is good, they say what they think is bad. Depending on the format, they either get to like tell you to change it, or they just get to vote that you should change it, or they vote on just whether it's good enough or not. For conferences, it's typically they vote whether it's good enough or not. Once you get all those votes, you read their strengths and weaknesses. Most conferences have something called a rebuttal, which allows you to write some response with some space limit saying like, okay, here's the answers to your questions and here's some experiments to like smooth out your concerns, or here's why you're wrong about, what's wrong with the paper. The reviewers then read that rebuttal and they make their final scores. And then the area chair, the person in charge of the reviewers, gives the actual accept, reject vote, as well as they bubble it up for rewards, like highlights or oral, which means instead of like, this will be at ECCV just as a poster. If I had gotten an award called oral, I would give a talk and like a whole auditorium of people would listen. You could also get nominated for like best paper award if you're like super good, like even the top crop of the orals or whatever. That's all the responsibility of the area chair. So what I used AI for with this paper was that rebuttal phase. I got all the concerns from all the reviewers and I fed it to GPT 5.4, 5.5, and basically just said like, do I have a chance? Because what I was actually using the chatbot for in this case was like, so like I do my best work on rebuttals when I'm in the mindset that things are going to work. And so I used my um GPT in this case to give me like the hope that it would work, but not in like a vapid or empty way. Not like you could just say like, oh, just like comfort me or whatever, and it'll tell you some like therapy nonsense. But what I wanted and what I needed was just like to see that a plan could exist. So I got its rebuttal plan, um, and it was not very good. Like it had extremely odd taste for experiments that I should run. I should go dig up those transcripts. Um, it wanted me to run some things that wouldn't work. It wanted me to run some things that wouldn't have mattered. And then it wanted me to run some things that I just didn't like. A couple of experiments that it recommended were fine. I don't think it's even fair to say that I really worked from its plan though. It's more like reading its plan gave me confidence that I could do something and helped me get like motivated to actually do it. I think most of the experiments I did have to plan myself though. But I did have it like write and run the experiments. So it wrote all the code for the follow-up experiments and it ran them. It handled pulling the checkpoints down, like getting everything wired together on the place that I was running it because like I wasn't at TikTok when I was doing this, so I had to pull down my own public code and public checkpoints to do the experiments for the rebuttals. That was very stressful, would have been very stressful, but GPT made it all pretty smooth. Is there anything in the poster that came from the rebuttal? I'm trying to see. I don't think so. I think all these experiments were the original paper. One really interesting thing is um it had this weird, okay, so this poster is not its version of the poster. I'll tell you what's different. So it really still struggles for me at least with spacing of things. Even when I try to grab nice like PowerPoint or poster skills, the author names, for example, were like touching the title. Another good example is maybe I should just see when I make the real video, I'll find the first version that it had and I'll just show you. But like the title, if you can imagine it, was here, I'll just draw on the poster. The title was over here. Um, I'll make it bigger. Can I make it bigger? Or is it lagging? Is that why we're here? Let me draw in red. The title was over here. This was the title, like If you can imagine it. Can we? Sorry, it's drawing super slow for some reason. It's like lagging out. I guess because the poster's so dense. I'm not getting like any. You guys can still hear me, right? I didn't like freeze the computer because it's not letting me draw. I'm making it angry. Okay. The title was over. Okay, I give up on drawing. The title was over here on the left. The QR codes were down here under key takeaways. And the ECCV logo was. I should stop trying to scroll. In fact, let's try to see if we can close this thing that I opened and fit the dang thing to my screen. We can't. This is the zoomed outest we get. Whatever. There was white space. This entire chunk was just empty. It had like three lines in between the top and like where the content started. And instead of these being in these nice blue boxes that I feel like I like to see in posters, it was just like plain text and it was left aligned. It also didn't have anything over here except text. This poster's already extremely text heavy for my taste. Part of that's because the paper was really text heavy compared to most papers I write. Um, a lot of results were just in tables, and I didn't feel like changing it a lot for the poster. So I had the AI make this diagram here, just to break it up like a little bit. This is actually the diagram that it initially made to explain INR. The only difference is it messed up the lines in the MLP for whatever reason. But everything else was from it, and honestly, I like it just fine. However, it had help, because I told it the search term to use on Google to find in Google Images stuff that would look like what I wanted. So I think it kind of was using the references. But this is correct, by the way. Like INR, you take XY input and you have RGB output. You have an MLP that you train it on all the XY RGB pairs, and it memorizes, the whole image. That is INR. This is a perfect diagram for that. Um, yeah, it had so the bottom of the poster in its version, like none of it lined up, and there was like crazy amounts of white space under some of it, and then the text would be like it was too small. It went like below the minimum font size I told it. I had to ask it like three times to make the fonts even like at the minimum. And it was just like they were all on little islands relative to each other. And then this section here was weird because like it wanted to talk about results kind of, but like not in a way that was connected to this. So I totally replaced that. It also didn't talk about the distillation at all, which is really bizarre because I let it outline the poster by itself. I gave it an example poster, and I was like, just here's the paper, here's an example poster, just go for it. It left out distillation, which, like, if you look at the table here, without distillation, my method doesn't do any of the things that the paper's about, basically, except the reconstruction. So I was like, how the heck can you leave out that? So I wrote this part from scratch. I left this empty and just told it, like, here's two tables in the paper, grab those, put them here. And so it did that. Also, the key takeaways, its original key takeaways were these items here, like the numbers. It just gave like these random numbers from the paper. And I'm like, a number on a metric is not a key takeaway. Like, why would you, like, what a weird thing to, I don't know, some of the mistakes it makes are just weird. It's funny because I often accuse it of being inhuman, but those are actually quite human. They're like at the level of maybe an undergrad, you know. Just funny though that it would do that, especially when I was giving it like nice examples. But anyway, okay, am I? Oh, nice beard. Got it, Kunte. Yeah, I actually wanted to shave before the stream, but that would have made me even later. Mathematics in the Age of AI, Terrence Tao? Sure. Did we? I think I considered looking at that before, but I don't think we ever have. Oh, no, let's not do it in this browser. Let's do it in the other one. Anyway, so this is something I made with AI. Like I made this diagram myself, but it like placed a lot of things. I changed the order of these, and I had to rewrite the captions. I rewrote all the text. If nothing else, because I'm really paranoid about it sounding like AI written, and that making people grouchy. I also just didn't like the way it said some things. So like all the text is kind of rewritten, but you can imagine the first version of this was basically like the formatting was a bit screwy, all the text was a bit different, um, and it missed like a very, very important part of the content. Other than that, it was fine. Um, it made the QR codes for me without me saying to, which I'm very happy about. I don't think it pulled these from a project page. I think it made these static QR codes that just point at the paper artifacts. Okay. So that's some of how I'm using AI lately. There's other things too. Like obviously I use it for all my work. But it's a little harder to talk about that because my work is like proprietary. So it's hard for me to even say what that means. Like if I have a 240 node job, I have the AI iterate on the important parameters for speeding it up. I tell it, like, I iteratively have to explain to it the things that we're going to have to implement to make it work at that scale. And then ultimately, I leave it in a goal, looping, managing, monitoring, keeping it healthy until the job is finished. That doesn't help a ton because like most things that can make the job get stuck, I still can't really let the AI handle. Like one example is if the shared disk runs out of space, the job will fail. And I can't have the AI making decisions about what to keep and what not to keep, especially because a lot of the time I'm not really the one that filled the disk. My job is writing some trivially small portion of data and somebody else downloaded something they weren't supposed to or like started like leaving their checkpoints laying around. So it can handle small things though. Like sometimes we'll get it all scaled up, but like there's one thing about some item or set of items in the data that we didn't think to handle well, and sometimes it can handle that on its own. Although often it'll just block on those things anyway. But at least I can log in and I can see, like I'll have it give snapshots every 5 minutes. I can see the moving ETA. I can see the number of nodes it thinks it's using continuously. That's something I'm trying to have Ultra do less though, because it's not like I really trust it to do a lot of intervention anyway. And often if you do let it intervene, it'll like you'll come back and you'll have a version of the job that's like 4 times slower than when you left it. Um, because it just kind of freaks out when things break and it does things. So I've been trying to put more of those in Luna so that they just kind of bubble up to me more frequently. Just because all it's doing basically is like running the monitor and reading the output. It doesn't really need to be Sol Ultra to do that. Okay, mathematics in the age of AI. Problem with me looking at this honestly is I don't really know a lot about mathematics as a field, right? Like my math background is more just like a CS major takes a little bit of math and now works in a domain that like is related to some part of applied math, right? But I don't really know a lot about how mathematicians work in their research. How long is this too? Let's see. It's not very long. Okay, we can do this. Maybe we'll, I mean, it gives a historical prologue, so he's going to explain it to us, right? Recirculation, do you think results are promising? We got recirculation open, Raj, so we'll look at that after this Terence Tao position paper. Okay, so this is an essay based on a lecture on how the math community should respond to AI tools. The hypothesis is that massive capabilities like performing research level mathematical tasks is a capability that if it's not here will eventually arrive anyway. So what the goals and values of mathematical research actually are. Okay. So that is the question that this paper is going to look at, which is interesting, because that doesn't necessarily have anything to do with AI. It is sort of orthogonal to it. Um, it can be orthogonal to it because I have seen some discussion that like some people do look at AI the same way other people look at art, which is like part of the point of it is just like human fulfillment and expression. So if that is one of the goals or values of mathematical research, then AI is maybe kind of bad. Okay, the problem-solving component of mathematics is used as a case study. Let's see. So historical prologue. I don't know the history, so we should actually look at this a little bit. Mathematics operated on naive foundations. Mathematicians proved theorems without feeling any need to say precisely what these quantities actually were or what a proof was. So those questions were left for philosophers. Mathematicians focused on mathematics. Um, but discoveries like Russell's paradox, Gödel incompleteness, forced mathematicians to Re-examine assumptions. Axioms of naive set theory contradicted each other. Formal system wasn't consistent, expressive, and capable of proving its own consistency. So, okay, so apparently there was this crisis in foundations for 30 years, but the end product was an explicit, rigorous, and standardized foundational framework. So he believes that this is a similarly turbulent era, which is interesting because the era that he's comparing the era of AI to is an era where basically they found that a lot of what they had worked on was even like self-contradictory and incapable of proving its own consistency. Like you couldn't even prove that something was consistent. But he says what's being stress tested is not the foundational framework for truth, but instead values and practices. What is a contribution? What should be rewarded? What is understood? Who or what does that work? Should do that work? And he argues it'll become necessary to make these unwritten goals explicit, but obviously people actually have to decide them. Okay, and this kind of sucks because like truth you can argue is absolute, but like the goals are always going to be kind of subjective, right? So the thing you end up with at the end of the day can't possibly make everyone happy. I suppose truth wouldn't make everyone happy, but the aim of truth isn't to make anyone happy, whereas the goals of aligning on goals is to make people happy. Or that depends. I guess you could say that the goal of having goals is to make sure that things move forward as much as they can, but that itself is a goal. So that's a little awkward too. It's like even the way that you approach codifying goals is itself motivated by goals. And those aren't like meta goals. You are a mathematician talking about how mathematics should operate. Like those are mathematics goals. So this is kind of impossible, right? Because it's sort of like a circular pursuit. Even deciding we need to write the goals assumes goals to begin with. Does it not? Anyway. Community response question. How should the mathematical community respond to the advent of modern AI technologies? He says it's not a mathematical question. It's a meta-mathematical one. It's a political, ethical, sociological, and cultural one. It can't be settled by pure logic. Hey, that's what I just said. However, he borrows precise and familiar language of math in order to clarify the structure of the question. At some point in the near future, some AI tools will, at some expense and with some level of human supervision, be able to accomplish some research level of mathematical tasks in some fields of mathematics with some non-trivial success rate and at some level of correctness and quality. Some is a placeholder. Fair enough. There's weak and strong forms of the conjecture. If even weak forms turn out to be false, then you could dismiss the current generation of tools as having no significance to the long-term practice of math. It's difficult to have a constructive discussion of 2.1 with the status of 3.1. This conjecture remains under dispute. So most of the public debate continues to be concerned with which version of this is true. Fair enough. And he himself says he's devoted a lot of time to thinking about that. There are lots. Okay, I am curious what he's going to say about this because as I read this, I'm like, do we not have proof of the weak version? Many data points on various forms. Most of them have not been gathered under controlled scientific conditions. But oh, fair enough. I guess if you assume that some of the people are lying about what the AI is used for, then that doesn't work. But he himself has used it in ways that would satisfy the weak side, no? Successes are announced and failures are not, but this doesn't like preclude failures, some level of human supervision, some non-trivial success rate. Maybe he considers already the success rate to be trivial, or is he going to say in his own experience, we already satisfy some of the weak, like we already satisfy the weak version of the conjecture. Let's see. To non-scientific incentives with important costs and variables, the number of attempts, the amount of human scaffolding, compute expended degree. See, but the conjecture already allows for human supervision and lots of compute. It just has some expense. The truth value of a given form of the conjecture is sometimes conflated with its desirability. That's true. People want there to be a certain answer to the question. AI companies want the answer to just be yes, 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 the strong form. Other people want things to be no, 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 the weak form. Decels, I guess you could call them. Decelerationist. Despite the central relevance of the AI capability question, this article is not about that conjecture. He'll mention the recent results of the first proof project. Each batch of the project is 10 research level problems. but have never been posted anywhere online. The second batch was evaluated under controlled conditions for systems, publicly accessible 3 months ago. 7 received at least 1 passing grade. Essentially flawless, requiring only minor revisions from at least 1 system, with compute costs on the order of hundreds of dollars per problem. That to me already suggests that unless we're really nitpicking, we satisfy the weak version of the question, of the conjecture. I don't know though. The complement to the capability conjecture. A reasonably strong version of the AI capability conjecture is true. AI tools will reasonably soon become capable of performing a reasonable fraction of research level mathematical tasks with reasonable levels of success, quality, supervision, and cost. This is interesting because he calls this reasonably strong. It sounds pretty close to, which fair enough, he says reasonably soon. I'm just saying it sounds fairly close to what he describes even in this paragraph here. Reasonable supervision and cost. I guess I don't know what the controlled conditions are exactly, but this sounds like very reasonable cost to solve a problem that matters. The precise meaning of reasonable here is not critical for what follows. For the remainder of the article, I ask the reader to assume that this hypothesis holds. Okay, so we're assuming, I would have called this honestly a weak version. He's calling this a reasonably strong version of his conjecture. So he's saying assume that this version holds, because yeah, without assuming some level of capability, it is pretty impossible to decide what goals and values can be. On the flip side, though, if you don't assume a strong enough version, we could also like this version still involves supervision. There are 2 very different discussions to be had with and without supervision, right? But I guess this is nice to know that it seems like maybe he'll have like some corollary like later that talks about what to do in a stronger version, but at least this version is still, it's not fully about like totally replacing humans, but rather just about AI that with reasonable cost can do reasonable things working together with human for math. So what are the goals, values, blah, blah, blah? What are the implicit goals? What does he say the goals are? This is his partial list of goals of mathematics. Solve unsolved problems, develop new theories, understand the world, build and sustain a community. Okay. So these like are like sort of aims of mathematics itself as a discipline in terms of like the like knowledge artifact, I guess it's trying to generate, right? This is like a social aim. Although the reason to care about the social aim is you would say that a community of mathematicians is able to work more effectively on the first 3 items. Same with this. Train the next generation of mathematicians. You could argue that like, math is actually a very human-centered pursuit, and like we care about the mathematicians for their own sake. I would argue that I think most people are caring about it mainly for, the way that training mathematicians means you'll have more people to solve these things in better ways. To contribute to the shared and cumulative network of mathematical knowledge. This refers to more the communication of the prior things and is kind of necessary for the maintenance of the community anyway. To create enduring works of aesthetic value. Okay. So this actually does, I kind of mentioned earlier, more than ever, I've seen kind of this discussion of AI as an art as it pertains to things like this, and also as it pertains, and also as it pertains to like the fulfillment of the striving of the human spirit that is working on the math problem, which I don't see that here, interestingly. Like I don't really see like the edification of the individual here, which is surprising because this seems to point sort of at that. Maybe that just doesn't matter to Tao. He says historically these have been positively correlated. So any of these goals could be proxies for the others, he argues. Which, fair enough. I was saying that kind of as we went. However, I mean, yeah, I guess these kind of require this, right? So even the ones that aren't social could be proxies for the social component. That's interesting, but I guess it's probably true. All metrics, when excessively optimized for, are at risk of being subjected to Goodhart's law. When a measure becomes a target, it ceases to be a good measure. AI tools are likely to trigger this because it's ungrounded. It optimizes for the appearance of a satisfactory output rather than for the underlying property the output is supposed to indicate. Do I agree with that? Uh, We actually do try to ground it a lot to like, well, it depends on what you mean by underlying properties. Um, if you think that its reasoning trace is more of like its intermediate state than it is an output, or more of like the way it processes the problem than the output, we actually do care a lot about messing with that these days, like in post training. Um, you could argue though that those are still outputs, right? And that we're just trying to make sure they're satisfactory. So fair enough. It's unusually good at finding the gap between a measure and the thing it measures. The second is economic. The financial incentives of the AI industry reward demonstrable, quotable, benchmarkable achievement on precisely the sort of metrics we have historically used as proxies. Yeah, fair enough. I mean, AI demands that you make stuff like this explicit goals that you then like point the system at them and then you try to maximize them. Uh, so excessive optimization for one or two goals may cause the many previously aligned goals to diverge from one another. See figure 2. Okay, let's look at figure 2 in a second. I'm missing chat as of 12 minutes ago. Sorry, Agent 355P. I'm really not sure how to consume something like this because it's kind of like a dense position paper. Like there's nothing to skim here, but I'm happy to go through it. Anyway, for a beginner to learn the theory of AI. You mean like learn machine learning theory? Like it depends on what you mean by theory of AI. I'll assume you mean like mathematical foundations, maybe, of AI. What should you start? Turing's papers or something else, and majoring in physics. So some math would also be awesome. No issues in that. Um, yeah, theory of AI. Uh, like a lot of the time when people say machine learning theory, they're just referring to like mathematical foundations and stuff. If you have decent math background, I think you could make quite a bit of progress getting into things with like, and no one like come at me with like pitchforks and whatever. I think this is a good book. I think, especially with like decent math background, I think you can get um, quite caught up on, I guess, what we can call most of the foundations. Oh, and I don't know if this is legal, uh, but here's the book. I'm pretty sure this is I think this is the same book. Yeah, it's the same book. Um, oh, look, a comment on this book by Elon Musk. Very generic comment by Elon Musk. Um, yeah, I own a copy of this book actually, like a physical copy. I think it's a good book. This would probably be a decent starting point. I'm trying to think, like, what else is a good... See, what I like about this is I can say this, and it's, like, very self-contained, right? I could also point you at, like, a million YouTube resources. Like, there's this Stanford Deep Learning course that's pretty good that you could find from, like, 2018 or something. I'm not going to try to look it up right now because every time I look it up, I don't find it at first, and then I feel like an idiot. Um, but you're looking for one where, like, the coursework, where, like, the homeworks are public and stuff, and you would do those too. Okay. Let me answer your stuff, content, then we'll get back to the Tau paper. I'm starting my 4th year in CSAI and plan to start an AI Masters at SJSU. Oh, are you already in San Jose? I wonder how close we live to each other. Um, August 2027, I originally considered PhD mainly as a path to work in the US, but with tougher admissions, funding cuts, and with a weaker application package overall, I'm leaning more towards research engineer roles that don't strictly require a PhD. Okay? Any thoughts or advice? Understanding deep learning is pretty good, I think. Um, is that a different book? Oh yeah, I've heard this one very highly recommended too, and it's more recent. Not that that makes it better necessarily, but like it could. And I think it still has a lot of the like foundational stuff anyway. I haven't read it though. I've just heard like good things. I remember when it came out, the initial review seemed to be good, and I've heard lots of people say good stuff since. Hey Tarun, Rajade, Raj, Rajade? I don't actually know how to say that. Sorry, Tarun. Tarun? Okay, let's get back to the Terrence Tao paper. So, um, you under excessive optimization, the goals of mathematics diverge from each other. Ah, okay. So he's literally just saying you could start to optimize one of these and it wouldn't have anything to do with the others. Fair enough. Case study, problem solving. Focus on the single component of mathematical research, problem solving, which is distinct, he says, from theory building. And he says theory building is at least equally important, but he's just going to focus on problem solving. So the goal of problem solving maybe is solve as many unsolved problems as possible. Even before AI, we knew this metric was inadequate. Optimizing it produces a large number of incorrect solutions to major open problems. Every working mathematician is familiar with the steady stream of reported proofs of the Riemann hypothesis, so they update their goal. Open problems, unverified solutions, proof verification, verified solutions. Solve as many unsolved problems as possible and verify them to be correct. I would have kind of assumed that was implied in goal 6.1, like by solve. But I suppose you can solve and end up with the wrong solution, so sure. Lots of correct solutions. Okay. So apparently there's a problem with this, though. What if an AI tool generates a lengthy proof that is verified to be correct, but which nobody understands? Which is a real possibility. So solve as many unsolved problems as possible, verify them to be correct, and ensure that the results can be clearly communicated to and understood by the mathematical community. Okay, so I think this is the first really significant part of the paper where he codifies some expectation that is not going to simply just result naturally. Like up until now, the paper is mostly like observational. Like he reports what he understands to be the goals of the math community. He makes conjectures that are like pretty much restatements of just currently what's happening and what seems to be the direction of things, but saying that we should ensure that the results can be clearly communicated to and understood by, I assume he means human members of the math community, is like not guaranteed. Like even now, people are generating like absurdly long proofs that can be very hard for people to process and understand, even when those proofs could have been simpler. So the writing often dwells at length on trivialities while passing briefly through, or even, he says, obscuring the most important parts of the argument. A proof can be too slickly written with the routine steps and the genuinely difficult steps presented as being equally easy to digest, which I would assume that part is like I often say things in my work with AI, the AI does things that are very inhuman. I suppose this is the thing that becomes inhuman that the mathematician has to deal with from the AI tool. In a human written proof, the parts of the argument that the author found difficult typically retain some natural friction, some apology, a very careful lemma, change the notation or a paragraph that's been rewritten several times, and the friction kind of stops you as the reader, right? And tells you what to slow down on. Whereas AI is going to remove artificial friction, so you won't really know what to look at. Oh, and Tao even says that like this is his own copy of a paper from 1991, and by working through the paper, he came to understand the author's way of thinking, which actually made him more interested in reading those papers. He also says, we are not trying to meet some abstract production quota of definitions, theorems, and proofs. The measure of our success is whether what we do enables people to understand and think more clearly and effectively about math. Which is interesting because like a lot of people, I think, outside math at least, will kind of separate math from like math ed, from applied math, from other things. But he sort of wraps it together a lot, like understand and think more clearly and effectively about math. That's almost like a math ed aim, like at the cutting edge of, what I normally think of as not being really related to math education at all. Fourth attempt at a goal. Solve unsolved problems, verify them to be correct, ensure that they're clearly communicated, and have them digested and accepted by the mathematical community. Yeah, I guess saying that they can be clearly communicated and understood does not necessarily verify that they're surfaced to the community in a way that they can actually be like digested and accepted. And it can't be optimized purely by the authors and their tools, which is fair, because if the authors chose to, like, I guess you can do whatever you want as an author, and still maybe you're just not trusted and everyone ignores you. That could happen. Yeah, because we rely right now on like editors, reviewers, referees, area chairs, editors, etc. Or I guess the referees here, the reviewers, the editors are like the area chairs. Fine. Yeah, editors, reviewers to provide acceptance. Yeah, and then we don't really, there's not a lot of recognition that you get for participating in that reviewing loop. The process of canonicalization is the slowest stage of all. Yep, like often I can do a project in 1 to 3 months, but submitting it to the conference, getting accepted, getting it presented, getting an award on it if it deserves an award, that can be like a 6 to 9 month process. But it is very valuable. I agree with him in that. You could consider it the most valuable part of the entire process. Okay, so update on the goal again, solve the problems, verify them to be correct, ensure they're clearly communicated, make sure they're accepted, and and they need to be incorporated into the definitive theory of the field. Um, Fair enough. Proof scarcity and proof abundance. If the working hypothesis holds, um, proof indigestion will emerge all along the pipeline of figure 4. AI-generated proofs will accumulate faster than they can be verified. Verified proofs will accumulate faster than they can be made readable. AI proofs, even those that are correct and well written, will overwhelm the peer review system, and even the ones that get through peer review would be too numerous to actually work into like the definitive form and theory of the field. So instead of having proof scarcity, they'd have proof abundance. And what's he saying about why that's bad? I can think of ways that that would be bad. And yeah, we've been experiencing this in ML before AI. I don't know how they've been doing in math, but like the growth and volume of papers is just crazy, and it's really hard for you to have enough trained reviewers to keep up with all the reviewers in training that are submitting the papers. The increasing length and specialization of major proofs. Yeah, I guess everything just kind of gets harder, right? That's how it feels sometimes. Like, I guess sometimes you kind of discover a new field and you don't have like 10 million things you have to have learned in order to understand it. But sometimes you are in the field where there's like just 10 million things you kind of have to understand all in order to understand a thing. Like, what if AI discovers 10 million more things? It just makes it harder and harder and harder for anyone to keep up with it, for anyone to like be able to review it, for anyone to be able to make it human readable, to be able to understand it, to be able to review it, to be able to like incorporate it into the theory of the field. Uh, it almost seems impossible. Yeah, I'm very curious what the recommendations are. Uh, okay. Identifying the goals is important, but he does not intend to propose a program. Instead, he points to, we've looked at this before actually on stream, the Leiden Declaration on Artificial Intelligence and Mathematics, which he says is a great starting point. He emphasizes disclosing tool use, support the needs of reviewing, affirm the humanity of authorship, and put effort into proper attribution. These seem all fine. None of these seem to even get close to being able to handle like the existential threat of proof abundance. Participate in public discourse. Like, this is all, I guess this paper is more of a conversation starter. I think, frankly, it makes things sound even more challenging than I would have thought they were before I read this. You basically need the AI to be good enough to handle these parts very soon after it becomes good enough to like move us into proof abundance. Like, you somehow need the AI that can help verify very, very well, that can help like with the like publication part, like the review part, and also with like the incorporating them into the definitive form and theory of the field part. And that means like you're not just using the AI to solve the technical problems, you're using it to solve a lot of the social problems. That sounds pretty hard to me. Okay, that's a lot longer, I think, than we'll spend on any other papers. I hope some people enjoy that. From India. Nice. It's good to have you here, Tarun. Um, oh, you're in Turkey right now, Kunte? Oh, okay, cool. Um, I answered your question, right? Or did I get totally sidetracked? How did I get did I read your question and then not answer it? That's crazy. Sorry. Um, AI with masters can be fine with even a little bit of research experience, even if it doesn't result in good papers. You can totally get like ML engineer or research engineer positions if you have like, although that would typically be if you have experience with a good lab, not like if you have no good research artifact and no participation in a decent lab, it might be a lot harder to find decent research engineer positions or ML eng positions. But if you're able to do some kind of interesting research while you're there doing the masters, uh, and if you're able to get a decent internship at like the midpoint, I think you could totally be set up nicely for some ML eng or research eng position. I've worked with plenty of people like research engineering, machine learning engineering that are like bachelors or masters only. The thing that'll be harder to do would be breaking into science. Like there's places that'll hire like masters or PhD positions for applied science roles. So that would be a way to try to break into that side. Is just look for like instead of BS/MS, you'd be looking for MS/PhD, which do exist. Like for example, this is not the right title for TikTok, but um, let's see if I still know how to navigate their site. Okay, this is, where can I see jobs, right? I'm curious. I swear back in the day they used to have some that would explicitly specify MS/PhD. Ah, here we go. There we go. MS/PhD for this position, for example. Some e-commerce recommendation. See? Ta-da. So you'd be looking for stuff like that. Some stuff will just hard require the PhD, but some stuff won't. Um, all right. I think that's my advice. Like, those are my thoughts. I don't really have advice. It sounds like you recognize that your application profile might make it really hard to get the positions you wanted. Um, so I think you're making a decision that makes sense for you. As long as you can afford, living in San Jose and the tuition at SJSU and all that, I think it's a decent decision. The nice thing about PhD would be if you were able to like get accepted to a program even at like SJSU level, that would give you funding, right? Which might make it like economically more viable. Granted, that does technically commit you to stay longer to actually finish the PhD, and so maybe you're not comfortable with that. Raj, now that I read papers nowadays, I think how much of hypothesis is generated by authors or AI. They will never quote it generally. I have only a few paper explicitly mentioning this. Yeah, I don't worry about it too much. Like rarely does the AI, I think, come up with like super interesting good hypothesis. But if it does, I don't really care. And like humans definitely come up with plenty of bad ones. Like maybe, I guess it would be nice for it to be disclosed more. I don't know. It'd be nice for it to be disclosed more if it wasn't like a powder keg, like, or if it wasn't liable to at any point incite a witch hunt, then I think it would be nice. But I'm also not really going to expect people to disclose these things when some people are so like bizarrely dogmatic about it. That just makes it tricky. I think it's important if a venue says not to use it, not to use it, like honor their wishes. Same thing for reviewing. Like when you're not supposed to. Reviewing is actually what scares me way more than papers, just because like I can submit the same paper to 3 different state-of-the-art models and get like positive and negative scores from different like it just doesn't really. I mean, reviewing is a subjective endeavor, but it feels really weird getting that subjective score coming out of like a jagged super intelligence. Like, what does it mean if Fable says my paper's a strong accept and GPT says it's a weak reject? Like, what? That's pretty weird, no? Maybe it's not weird. Like, human experts have already been diverging in those exact same ways, but it seems a little weirder too that sometimes I could optimize that acceptance if I simply know what AIs are being used. And I could try having them review the paper over and over, and I can optimize for things that I know they like without making the science better at all. That feels pretty weird. And I don't know how far away we are from being able to solve that. Like, it would literally be as if you knew up front who your reviewers were going to be. Like, what if you knew your reviewers are going to be Matt and like 2 of my friends, and you knew their papers and you knew their taste? That totally changes the paper writing process and the paper submission process. So it is a little scary that it's like there are 2 truly frontier models, and anybody that doesn't want to do their own reviewing is like fairly likely to throw it off to them in some capacity. So it's kind of like a priori that who knows who my human reviewers are literally going to be, but there's a decent chance that some version of GPT and some version of Anthropic's models are in that loop. Anyway, let's read this recirculation paper. I had a friend share it. I actually didn't even look at like the abstract, so I have no idea what this is about. It's an inference time architectural enhancement for off-the-shelf foundation models to reduce the perplexity and boost the accuracy across generation reasoning tests. Okay. This basically just means like make it perform better, not faster, just better. It's going to give more good responses, more good results. Our approach incurs essentially no additional latency. And so it's not even slower. I mean, it says essentially, so it's literally slower, but apparently not in a way that matters. During generation, but it makes prefill serial. Okay. So it has a latency penalty. Motivated by the fundamental limitation that state updates and feed-forward transformers are bounded by model depth. Their technique, recirculation, introduces a specific form of occurrence that allows the model to act as a dynamical system and track belief states. They distinguish the technique from chain of thought, which is better reserved for complex inferences rather than basic state tracking, as well as from popular depth recurrence. Okay, so it's not looping. It sounded like looping, except for where they said track belief states. Well, it also acts as a dynamical system. It's not clear to me that it's straight up looping, but just maybe routing through the blocks like out of order, repeating some, etc. I mean, recirculation certainly implies some level of repetition. So let's see. We also propose and evaluate an adaptive variant of recirculation, which requires only light tuning of hyperparameters while freezing original model weights. Okay, wait, does recirculation originally require tuning the weights? How is this a variant? Whatever, we'll see. Relative to the off-the-shelf baseline, adaptive recirculation achieves remarkable gains on the Gemma 3 family. Oh man, I guess they started the paper forever ago. Gemma 3? Bro, it's August 2026. What about Gemma 4? I swear we've had Gemma 4 for like 4 or 5 months, no? Man, I hate academic work sometimes. Like, I like that it can be interesting. Well, this is Google DeepMind. Why is it on Gemma 3? Maybe it just got stuck in legal for like 10 years. I don't know. That's just a bummer to me. It's fine though. Okay, 21% increase in accuracy on GSM 8K, reliable improvement in accuracy on other downstream tasks, and their training-free approach succeeds by leveraging the model itself to inform architectural modifications. Suggesting a route to architectural evolution guided by training network's properties rather than forced arbitrary design choices. Okay, so let's... Oh, and this was an intern project, right? No, an intern just participated. Interesting. Not an intern project, but they had an intern, and they put them, like, next to last. Interesting. Let's see. Oh my goodness, do I see Procrustes? Did I see that? I didn't, right? No, I didn't. Okay, that would have been fun. So let's see. This is the example. Okay, example of a contextualization error that results from a failure to track state from Gemini 2.5 Flash. Fred took the day off work and pulled out his fishing pole. He drove to the bank, reaches the bank, show you where boots or flip-flops. They are not the best choice for fishing, especially at a riverbank. Is it likely that Fred will find an ATM at this bank? It is highly likely that Fred will find an ATM at this bank. Okay, I see. So the original statement is like a little ambiguous. In fact, in my brain, I did not even think riverbank. I thought like he stopped at the bank on the way to fishing. But the model, I guess, correctly knew that it was the riverbank, but then forgot that it itself knew it was the riverbank. So, or heck, maybe it even thought that this riverbank was like a bank with an ATM. I don't know. But they're making the argument that it knew that it was the bank, like a riverbank, like just a sandbar at a river, and it forgot and decided it was a real bank. They're saying that while newer and more powerful models are less susceptible to the error, it reveals a fundamental weakness of the core architecture. Does it? I guess if we expect the models to just be arbitrarily smarter than humans could possibly be, but I don't think, I mean, depending on how much happened here, I don't think this level of forgetting, it just depends on how long it, like if this was a couple turns, sure, especially if it really knew before, but if this is like a ton of turns, who knows? Like this bank is also kind of ambiguous and the model does, like I find that I benefit from this kind of thing a lot, where like the model has to take something that's like technically under constrained, um, and just make the best possible assumption. And in this case, the assumption it makes happens to be wrong. But it had to make some assumption. It's not like this is verifiably wrong. It just happens that this user was still referring to this bank as opposed to Like in some cases, I'll misspell like the as this, and I'll have to go back and correct myself, right? Or like I'll say these instead of the, and it can change the meaning in ways like this, right? But the model is not just trying to like factually answer exactly the user query. If it did that, it would fail to handle many user queries in the way the user wanted. The model simultaneously has to try to infer the user intent. Um, and this is a pretty weird question for the user to be asking. So like it would, in terms of what the question literally says, sure, the answer's wrong. But in terms of what the user is most likely to intend, unless the user is specifically stress testing the model, why the hell would they ever ask this question? In the vast majority of cases, the user would have misspelled the word this. They would have written this instead of the. It's pretty weird that like it's set up this way. Is all I'm saying. Like I'm not saying the models are perfect. I'm just saying that as someone that benefits from the model inferring my intent, even when it contradicts, me accidentally writing the wrong word. Okay, I'm caught up with chat, which is both a good sign and a bad sign. Chat's not moving fast, but hey, I'm not behind. Okay, so schematic depiction of transformer activations in processing the example of figure 1. The grid of rectangles denotes transformer blocks uh, with the rows corresponding to network depth. Bottom to top is shallow to deep, and then input. Okay, so we're doing words across this axis. We're doing transformer blocks this way. The depth of state representation of transformer can limit its utility for inference because we can only move this way, right? All of our flow is restricted to go this way. We can go across blocks and things can move like across words through blocks. Basically, we can only ever go this way, right? And technically, we can only go this way, right? Like, but that means essentially we can move this way. Like when we're here, information here can move here. It also sort of has a way of moving here, right? Not literally. I mean, it literally can if we decide to keep those intermediate states. Those exist. Um, but our standard inference progresses this way. They add this. I suppose this is recirculation, this orange line. It pushes representations from deep in the transformer to shallower layers, which makes the state available for information processing. I think this is going to rely on the way that things work in like the paper transformer layers as painters, which basically shows that like, especially because of how the residual connection works, transformers don't like radically change the states as they process them. They just make like little tweaks as they go. So like you can basically take the representation that you tweaked three times here, and you can like tweak it again with those same layers doing their same jobs just on a representation that's already a little further along. This so far just looks like looping though. So I want to see how this isn't looping. Do I need to read the text to know how it's not looping? Oh God, maybe. Maybe. Okay, running an LM step by step, and after each step, leaking a bit of the activation from a deep layer down to a shallow layer. Oh, always a deep layer to a shallow layer? Recurrent arrow specifies one possible source and destination layer output. Because this figure does not depict how recurrence is orchestrated with regard to input steps, it's ambiguous. Uh, okay. So they acknowledge themselves that even figure 3 is ambiguous and could show looping. So what is looping? How is it different from recirculation? Whereas a standard transformer stacks a deep sequence of unique transformer blocks, a looped one has a set of shared blocks multiple times. Figure 3b is going to depict a loop transformer by unrolling the architecture in 3a vertically in depth and unrolled horizontally input steps. At step 1, the activation stack is computed, and at layer 6, the activation is passed to layer 3. That's looping, yeah. So figure 2 showed looping, figure 3 is going to show some looping. The colored rectangle denotes the current blah, 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 blah. Figure blah, 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 blah. Okay, recurrence in a loop transformer is solely in depth. True. Recurrence in circulation is both in depth and step. It collapses together the operation of figure 3b's top stack is step I and the bottom stack is step I plus 1. So two input stacks are run in parallel at each recurrence step. What? We need the figure. The difference it fundamentally changes the nature of computation. Okay, to implement an arbitrary state updating function over time. Um, in recirculation, where there's a projection of both depth and step, the same layer can hold both z of t and z of t plus 1. The cost of state tracking is that sequential passes must be made through the architecture. Because of the sequential updating, recirculation cannot be parallelized, even when an entire input sequence is provided, such as during prefill. Wait, does this also mean that we can't do like multi-token parallel? Because that kind of sucks. And would that make it harder to do? I don't know. I guess for everything else, it's kind of fine. Um, we need to look at the diagram. Then we can maybe come back to the text. Okay. So 3A is essentially the way it's drawn could just be a looped transformer, right? We just take some late layer and we go back to an early layer and we process again. Even unrolling it yields a looped transformer, right? We are going to skip these two blocks, and we never did this one here. We're going to go straight to here. And so we're going to go 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7 output. And we could do that at like any step based on, we can loop at different points, but that's still ultimately loop transformer. So unrolling in both depth and input steps yields recirculation. So let's see how that works. So, um, oh, so we reprocess like, oh, that's why the prefill has to be serial. Oh, that's pretty weird. That seems to immediately, I didn't know quite how bad it was going to be when they mentioned serial prefill. Like, they literally have to do one token at a time prefill. Because when you take the next token, you are like getting a new hidden state for the prior token, which depends on that prior token having been fully processed. Jesus. And then it looks like eventually you can do some kind of skipping. It just depends. So we can reprocess for any word starting at any state with any like later state. Man, would this ever be, how good would this have to be ever be practical to do? Because prefill is one of the things that you just like gotta have for a lot of applications. Parallel prefill, I mean. Um, Unrolled loop transformer right here. See, we're never like reprocessing state. Unrolled recirculation transformer. See, we're like reprocessing state from prior step. So state propagation can continue indefinitely in the same layer of the stack. It's fine. Anything else we want to look at here? We spent a lot of time to understand that. I kind of don't want to spend too much more time to learn about the layer selection mechanism. Maybe I can just leave that to y'all if you're like super interested. Look at it on your own. Um, they make the main argument in terms of first perplexity, which is not. It's a good argument because it's like a indicator of performance for like the base model that should then show up in terms of good performance on the downstream tasks. But then really we do just care at the end of the day about the downstream task, which they do say, if I remember, that they increase the performance on the GSM 8K, right? At least that's one of the tasks they have. Man, they're showing us a lot of like perplexity stuff, which is fine. But let's try to look at like if they have other task results. This seems to be an interesting results section. If I wasn't already kind of burned out on the paper, I would definitely look closer. Okay, so this is their GSM 8K. Baseline versus recirculation has a small improvement for like serial prefill, but at least we can get a much better result. But I wish they did a stronger model. Do they at least do the larger gemmas? 4B so tiny. Like, is this going to vanish once we get up to like a larger model? Interesting. Anyone got questions about this one? Let's see. Raj asks, what if those questions can be generated as chain of thought, not directly user queries? Um, I mean, if you're saying like these kinds of questions, it doesn't matter if the model answers this chain of thought wrong. In fact, it says weird stuff in this chain of thought all the time that doesn't, I think, matter too much. The chain of thought is like the model's internal way of getting to the goal. It doesn't necessarily like totally need to fit whatever like the human the chain of thought does not need to be eminently human readable or like aesthetically pleasing to human. Hi Alina, how's it going? Okay, so that's recirculation. I'll be interested to see, like, maybe I'm totally overestimating the extent to which the serial prefill issue matters, but to me it seems like that matters a lot. And who knows, maybe this is actually really extensible on other architectures. It's already a bad sign though. When they said 21% improvement on GSM-8K, I thought they meant like Gemma 3 is terrible on GSM-8K, so this gets 60%. But no, they meant 20% relative improvement, which is kind of bleh. So I would have loved to see results on more real-world tasks and would have loved to see larger models on those tasks. Probably someone will try it soon and say something, and either we'll see this a lot more in a lot more places or we won't. I do think though that it continues to provide like valuable understanding of the way these work. Transformers, I mean. Just the fact that you can do this kind of the fact that you can introduce these kind of structures in the network at all and that it works. Even training free. Okay, let's see. We got some other papers. I need water. I think I've got enough energy for 5 more papers, especially if we don't go quite as deep as we did on the others. And I wanted to go deeper on those papers because Raj asked for them specifically. But let me grab a little more water and I will be right back. Hang on. And I'll type in the chat too, BRB water. Okay, I'm back. Let's switch the scene. Got it. Great. Okay. So Hydra Zero. Friend of mine shared this in some chat. I haven't looked at it at all myself. Y'all have been watching their demo video, I guess. What's the deal with Hydra Zero? Predict what a command will do on any robot. Oh, is it video generator? Does it generate the video? Does it generate the final state frame? Okay, so because I see simulation, policy evaluation, so it predicts like success fail, or is it predicting these in visual space? These still seem visual, right? Um, it learns from diverse interaction videos. In forward mode, I don't really like this. I'm going to the paper. It's not like giving the details in the order that I would want the details. Generalist world model condition on action flow. Oh, it's calling it action flow, but it just says which represents robot actions as pixel motion. The shared visual interface enables generous world modeling and control by learning action consequences across embodiment tasks, environments. In video generation backbones, our best configuration achieves low robot motion error and lower object motion error than our action condition baseline while supporting zero-shot composition and data efficient adaptation. On the RoboLab benchmark, some nice results. Okay, so potential of action flow as a shared control interface connecting heterogeneous training data, open loop policy evaluation, robot control. Shared action flow looks like RGB plus point tracking input. Is that, can I get like a method diagram? This is killing me. Video derived action flow. Tracking the embodiment and the manipulated object. The future video is encoded to construct the flow matching training target. Okay, where is that? Literally the video. Okay, the video itself is the target. So it wants to take a video with the point flow of the embodiment of the object as input and predict the future video as output. And that's the action flow world model. And they do some AR training to get a causal world model, which has autoregressive rollout based on... I'm still a little confused. What's an Isaac Lab rollout? And what's camera projected action flow? Like, are they predicting flow based on sims? So they have a real image and then they get predicted flow from simulation. And so like with the image and the predicted flow, they try to predict the future video. I'm still a little confused about how this data is paired. Okay, the robot receives an RGB observation and executes an action. An encoder maps the initial observation to a spatial latent state. They represent the action sequence by flow F. And let the dynamics model predict the future latent sequence. A decoder produces the corresponding RGB sequence. Figure 2 provides an overview of the resulting world model. I mean, I'm still feel like I'm missing like 3 things when I look at this diagram. Rather than conditioning them all directly on embodiment-dependent command, we map the command to action flow, a set of camera plane trajectories describing the commanded motion of the visible robot embodiment. For n tracked points, we write the image plane location of point n at time step as visibility, blah, blah, blah. So we have all the points, and we have their movement over at lots of different times, right? Okay. Because this is expressed in the observation plane, the same interface can represent robot arms, grippers, and even human hands without exposing their native action spaces. When robot geometry and camera see what I want to see though. Okay, so we're going from T0 to H, right? For our inputs, for our tracked points that are in the input. So the output of this model. What are the time bounds of that? Because this says it goes from 0 to H. So that's not the future. That's the present. Right? Do you see my problem? Oh, or okay, so do we get, is it, oh. is it image? And then on the first image, we just add the flow of points, and then the target is the actual pixel video. So it gets pixels for t equals 0, it gets points for t equals 0 to t equals h, and it predicts pixels for t equals 0 to t equals h. That would actually make sense, because then we can just give it input by like trying to predict what the flow would be, and then actually predicting that video. But what if I mean, predicting this is the hard part. Like projecting the action flow is challenging. So is this like a checker then for whatever this is? What the hell is an Isaac Lab rollout? Okay, we're making progress though. Geometry aware construction. When a robot geometry and camera calibration are available, sequence of robot states and link transformations. At deployment, Isaac Lab produces the sequence by executing the candidate command through the robot control. Okay, so we get a candidate command, we execute an Isaac Lab, and we get the sequence of points from Isaac Lab, which executes the robot controller in the physics simulation. So the world model is not then responsible for actually simulating like the most load-bearing part of the physics. That happens in Isaac Lab. We propagate the sampled surface points using these link transformations and project the resulting motion into the camera plane. Yeah. Which basically just means like we figure out where all the points are like relative to where this camera's looking, right? So we get all the points as they are from the perspective of the camera. Many large interaction datasets provide videos but omit robot description files or camera calibration. For these data, we first recover dense image plane trajectories and visibility labels of the flow tracker. So these are flow tracker. Then they segment the tracks using grounded masks for the visible embodiment, which produces the trajectory representation. Okay. I'm still trying to get to how what we see here turns into all the outputs that they have. And I'm also not sure why they're doing it autoregressive, but they say they are. I mean, this makes it look like it's bidirectional and then adapted for AR, like in a two-stage kind of manner. Over a horizon of 8 steps, our kinematically grounded video predictor produces future observation condition on action flows as. For motion conditioning, we retain the spatial structure. Okay, sorry. I know I'm probably getting way too into the details here to be interesting to most of you. It's still interesting to me, but I should try to come up for air a little bit and make sure I just get like the really important thing here. Okay, action flow is visual conditioning. Action flow trajectories propagate first frame latent features through time to form the motion aware visual conditioning C. Condition C, motion, where? These are the first frame features. I'm confused. Like, it looks like it's mostly the image that gets encoded here, not any of this crap. But we somehow propagate those features, and then we end up somehow with this visual condition, which I don't understand. How? Oh, they like take these features they get here and then they just like move them along the trajectory to get the visual condition. So in a way they get like this fuzzy feature movement, and it's just got to like, and then so even their generator is almost like a reconstructor in a sense, because you're telling it like where all these patches hypothetically move. It's kind of weird. This also seems to be like really tightly coupled with the formulation of robotics problems where the camera doesn't move. Am I not totally boned if the camera moves and reveals like new objects, for example? Like, what do I do if it's not just this one object in frame, but if I have to like turn my head and look at something that's like in another frame? And then I don't have like the first frame features for the object anymore. What do I do if my camera looks totally away, like if my head camera looks up and away from my hands or away from my embodiment? Maybe those have obvious answers, but they don't seem so obvious to me. Ooh, autoregressive conversion. Joint bidirectional denoising assumes a complete action horizon and repeatedly paceful window sampling cost. So they reuse this autoregressive conversion. So during rollout, generated chunks replace the clean history and are reused through KV cache. Okay, so they yeah, so they convert it to AR and they also use DMD for few subsampling for like efficient causal rollouts. That makes sense. Okay, the thing I wanted to resurface and understand is like how it handles all the tasks that we saw in the teaser. But I thought I would really be getting that just from being in the paper, but it's like, how do they go from predicting the frames to like I get how that's simulation. Like see what it looks like? That part I get. I don't understand where policy evaluation comes from. And I don't know what they mean by policy learning. In forward mode, the model receives grip or flow computed from a robot command or achieved robot trajectory and predicts the resulting video outcome because the target is the observed consequence rather than a prescribed behavior. Any executed trajectory can provide forward dynamic supervision regardless of task success. Our open loop policy evaluation uses achieved trajectory replay. The complete recorded grip or motion condition is fixed before. Okay, I still don't understand. We evaluate whether Hydra Zero preserves policy outcomes under open loop replay. Okay, starting from each rollout, it receives causal action flow derived from the recorded robot end effector trajectory. The policy is not queried. The RoboLab study evaluates following a prior. We compare. I still don't understand. Like, my best understanding is like recorded reference trajectory and the corresponding open loop prediction. So my understanding of the policy evaluation is just basically like um does the robot in the simulation do the same thing that it did in real life for cases where we actually did the thing in real life? And I don't understand what the evaluation aspect of that is, though. Does it just mean like a VLM can look at? Does it mean because the rollout is correct for the motion that a VLM can then like look at the start and end states, or any verifier can look at the start and end states and see like, oh, this worked or this didn't work? I guess that's what it means, right? So it's policy evaluation because it simulates the actions. Like to me, it seems to like roll back into simulation completely. It just is simulation. But then what is policy learning? Oh, that's the only place in the paper it's mentioned. I'm not going to think too hard about it then. Okay, that's Hydra Zero. Chat is empty, for better or for worse. That makes me scared to look at the concurrent viewer count. I'll look and see if it's zero, though. I shouldn't be streaming to 0 people. That would be a bad use of time. But no, I think there's still some of you here watching, so we'll keep going. GenRec, knowing where to reconstruct and where to generate. What is the point of this paper? Generative novel view synthesis. It's 3D. Okay. From sparse input images is really all reconstruction or all generation. Pixels visible in some source views have unique correct value. True. Existing generative novel view synthesis methods conflate these regimes under a single uniform loss. Sure. So we can hallucinate stuff where like we even had the ground truth already from that position. So they introduced GenRec, multi-view flow matching model that builds the reconstruction generation split directly into its architecture, supervision, and gradient flow. It's guided by an observation mask, a flow matching backbone, jointly denoises the RGB and scene coordinate maps across all target views, while a pixel space refinement stage restores high frequency detail and observed pixels. So they're going to have a mask anyway, and a depth estimator, but they're also going to have a pixel space refinement stage to restore high frequency from observed pixels. But could that not end up creating like a lot of like visual artifacts if you have really high frequency unobserved pixels, but the generative pixels are just kind of I don't know. The same mask gates supervision, so regression signals do not contaminate the generative prior. In both single view extrapolation and 2-view interpolation, GenRec attains the best reconstruction fidelity in observed regions. Oh, that's cool. So they're like synergistic somehow, while surpassing purely generative baselines in perceptual quality in unobserved ones. showing the effectiveness of our approach. Let's see. I kind of want to just look at the results, honestly. Like, okay, let's look at their method diagram quickly, and then let's just go look at the results. So, yeah, what they're saying is that they have this. Oh, I guess they're actually just pitching it like this. They have the same inputs, like the warped point cloud and the pluck arrays as input. I don't know what pluck arrays are, by the way. Kind of barely know what a warped point cloud is. I assume it just accounts for the fact that the scene is 3D, but we have to like lay it onto 2D for this 2D image video model. We take the output of the generative model and pass it through observation-based 3D sparse reconstruction model, which is like that sort of pixel high frequency refinement stage. I wonder how that model is going to be constructed, and that just has pure reconstruction loss. And that gives us the generative novel view. But we did make some changes to the generative model also, so I want to see what those were. Okay, so here's our warped point cloud and our plucker arrays. There is a reconstruction branch, but that, to be clear, that branch is strictly after the generative model. What it's going to do is it's going to take the source image, like this 2D view as input. It's also going to take the generated, so it's going to take, what? It's going to take like the source point. Okay, what is iSource? I need to make sure I know for sure what iSource is. Hang on. Let's make sure I'm clear on that, because that's really, really, really important. Okay, so iSource is just any of your input images. So which one, does this just mean all input images here? Because you get lots of source views. So this is some actual source views, and this is the generated novel view from the generative backbone only. We are going to do cross attention with the source views. Okay. So it does retrieval, but it's a transformer-based retrieval, right? It's not literal pixel retrieval to literally grab those pixels, but we're trying to do the retrieval through the cross-attention mechanism. So we're going to do cross-attention with the source views, then we're going to do self-attention once we've already processed that information but we're also going to inject, oh, and these are time step aware ResNet blocks here, so some conv layers here to finally get like the eye, like the generated view, which has the reconstruction information. What is SC hat? What is SC? Let's try to find that, huh? Ugh. Sorry for the yawn. I don't understand. Decoded scene coordinates. Okay, so each target view comprises two co-register modalities, the RGB image, yes, and a scene coordinate map, encoding the normalized world space yeah, because the pixels exist both, well, first off, relative to camera they have XY, but in the world they simply have absolute position XYZ. So we have a scene coordinate map. Where does the scene coordinate map come from? Right here. Okay, so it is predicted by our generative model. Okay, so we take the generated image as input as the queries. We take these some source views as the key value. How do we know which source views to take? Or do we take all of them? It does say source views, so I assume it's all of them. So all the source views, cross attention with the generated image as query, and then self attention with somehow injecting the scene coordinates, which were predicted by the generative model. How does that injection work? So this is no. Okay. Sparse source to target attention. The first attention block, I don't care. Nope. Don't care. Okay, I still don't care. Nope. Or do I care? Per view, source to target attention may produce refinements that disagree where different target frames observe the same surface. True. Um, yeah, because the pixel value will look different depending on which angle we observe it from. Um, and anyway, there's lots of different refinements to, yeah, the one view could imply one value, a different view could imply another value. It has to reconcile those somehow. So a second attention block reimposes consistency by reusing the same operator, but with a neighbor set now constructed across target views. Wait, the same operator? But it says it's self-attention. Huh? How that the same operator? That doesn't seem like the same operator to me. Neighbor set now constructed across target views. Oh, I suppose because the neighbors aren't source views, the neighbors are target views. Ah, so we end up with multiple target views? Oh, is that a detail I should have gotten from here? The first attention block operates at full pixel resolution for each target view I. Queries and values are built from the per view tensor, and keys are produced by encoding the source images with a VA initialized encoder. To avoid quadratic cost across all source pixels, we precompute for each target pixel n the indices as k geometrically nearest source pixels using the scene coordinates in the source point cloud and restrict attention to that fixed neighbor set. Okay, so we reuse that operator, but the neighbor set is just built across all the target views. Oh, so we kind of need multiple target views, huh? K geometrically nearest, yeah, okay. So we originally do the retrieval against other source views, but now it's just whatever target views we had in the generation. So I guess it has some dependency then on like some minimum number of target views, which makes sense because typically we want to reconstruct the whole scene, not just like a piece of the scene. And this would also guarantee we don't have any like jaggedness by like suddenly jumping to different frequencies as we go between like source and target views. So it guarantees, so gives us some smoothness. Like the source views give us that jaggedly correct high frequency information. Not literally like copy pasting high frequency, just the pixels we see. Like already like the cross attention is going to implicitly do some blending, I guess. But then this really blends it because it just enforces consistency among the target views, which got some consistency originally from the source views. So these two attention blocks carry a lot of like responsibility, I guess. Because then we just have some time step aware ResNet blocks. Okay. Okay, I think I understand what I wanted to understand. Now let's just look at some pretty stuff. Input, ground truth, genrec. This isn't how 3D demos are supposed to look. These are images. Why am I looking at images? And they're not even like full screen enough for me to see that theirs is better. Huh? That's not pretty. Okay, so then they build the Gaussian splatting or... Oh, they do have a play button. Do they have a play button everywhere? Okay, no, just here. Okay, so the resolution's clearly degraded. Don't know why it has to be so degraded. But, huh. Okay. Genrec. Let's see. Do I still have anyone watching? I think so. Like a couple people. I was curious to know what this is. T-pips, it's clearly supposed to be related to L-pips in some way. I guess in the sense that it's some kind of perceptual score. Human visual similarity judgments are context dependent. They might be similar in shape but distinct in color, but existing perceptual similarity matches like L-pips. Just look at the features, so they collapse these nuances to one scalar. Okay, so here's the thing. They talk about single scalar. Like, it's nice to complain that single scalars aren't granular, but the nice thing is they're like really easy for people to understand and process. They're also easy for models to use. You can feel like you're doing something really cool and important when you turn one score into 5, but you also just made it like arguably more than 5 times as complicated for like really specious benefit. If anything, the hard work is in collapsing those 5 back to a single score, right? But maybe they do that and maybe it works pretty well. What's the method exactly? Do they have like a good method diagram? Maybe. To supervise our pairwise similarity model, we convert models' pairwise similarity scores directly into odd one out prediction. We fine tune a base VLM using 3 approaches. Okay, so they're going to use VLM features instead of like VGGT features. And they're going to try to get the VLM features to give them those same kind of similarities, but on like more granular level, I guess. They're also going to look at like proprietary stuff apparently. They're going to compare like proprietary closed stuff to like open source stuff to their stuff to humans and see and basically they're trying to prove that their model is always voting where the humans vote compared to the other models that vote in very unpredictable ways. Okay, so it does look like they boil it back down, kind of. Well, no, but you still need that text condition. Like you can ask it about camera viewpoint preference, object color preference, composition preference, I guess. Do they have like canonical scores, or is it just like arbitrary text inputs? Does this allow for like just on the fly preference, basically? Um, it says freeform text prompt, so yeah, I guess you could basically like customize your pips score depending on individual preference, which is neat. Because you could, if you want one score, end up with one score again, just by always asking the same question. Like you could say overall or something. And then hopefully get something that can outperform LPIPs or whatever. Okay, that's cool. Cool paper. This is some diffusion scaling work from Luma, which I don't know how much detail I want to look at the scaling law paper in. I'm almost like out of energy to look at a paper like this. I feel kind of weary. Oh man. I've already done a lot of deep dives and my chat's pretty dead. Yeah, no chat for 30 minutes. I think I'm good to call it here. Maybe I'll look at this one next time. Hypothetically I work on diffusion scaling loss, so I've looked at the paper a little bit already. I might look at it with y'all next week. Uh, anyway, it's been a nice stream. Thanks everyone who watched. Join the Discord for updates. I guess I'll drop the link in the chat for anyone that's still here that maybe isn't in the Discord. And I have a couple videos I want to make. It's all contingent on having time and energy to make them. Hopefully that happens. But yeah, until next time, take care. Thanks. Bye.